Today, we're diving into something literally fundamental to staying alive. I want you to think of your body's energy management like a highly sophisticated 24/7 banking system. In this biological bank, the currency is energy, and the tellers and branch managers making all the crucial decisions, those are your hormones. Whether you've just eaten an absolutely massive feast or you're stranded somewhere without food, these chemical messengers are constantly orchestrating deposits and withdrawals just to keep you functioning. Today, we're going to unpack exactly how they pull it off.
Okay, let's just dive right into it. We'll be walking through a chronological journey today. We're going to cover the engine of life, feasting and storing energy, fasting and releasing energy, the stages of starvation, and finally, stress and other hormones.
All right, Section 1, the engine of life.
So before we meet our chemical bank managers, we kind of need to understand the bank itself. You hear the word metabolism tossed around all the time, usually when people are talking about weight loss, right? But technically speaking, it's the sum of all those microscopic intracellular chemical processes converting nutrients into cellular components. But to strip away the jargon, metabolism is simply the constant 24/7 hustle of your cells, making sure you have the exact right amount of energy to stay alive literally every single second of the day.
And this brilliantly illustrates how that hustle basically relies on two main gears. On one side, we've got anabolic reactions. Think of this as the body in saving mode, taking tiny puzzle pieces and using energy to snap them together into big, complex storage units. On the flip side are catabolic reactions. That's your spending mode, where the body essentially smashes those big molecules apart to release the trapped energy inside. Your body is constantly carefully balancing these two.
So where exactly are we hiding all these savings? The numbers here are just staggering. We store carbohydrates as glycogen, but it's a relatively small stash. Protein gives us a modest emergency backup, but fat is our massive long-term savings account. I mean, it makes up 25 to 35% of our body weight and can hold up to a mind-blowing 165,000 kilocalories of stored energy. That is a massive reserve.
Moving right along to Section 2, feasting and storing energy.
Now let's see what happens to those accounts when payday actually hits. During what we call the absorptive phase, which is roughly 2 to 2.5 hours right after you eat, take a look at that massive red spike. A huge wave of nutrients just floods your bloodstream, and blood sugar absolutely rockets upward. Now, we need sugar for energy, of course, but too much of it, a state called hyperglycemia, is incredibly toxic to your blood vessels. So the body's absolute #1 priority right now is stopping that. It has to get all this loose cash out of the lobby and securely into the vault fast.
Enter insulin. Think of insulin as the strictest bank teller you've ever met. The second blood sugar spikes, insulin rushes in to force all that excess glucose out of the blood and lock it away in our fat and muscle vaults for safekeeping. It's basically yelling, "Stop breaking things down, start building." It promotes glucose uptake, kicks fat storage enzymes into overdrive, and explicitly orders the liver to stop making new sugar. That's a process called gluconeogenesis. Insulin is, without a doubt, the ultimate anabolic hormone.
Which brings us to Section 3, fasting and releasing energy.
All right, so what happens when the feast is over? For the 12 or so hours a day when we aren't actively processing a meal, the interdigestive phase, the mission totally flips. Right after eating, remember, the body was desperately fighting high blood sugar to protect your vessels. But between meals, it's desperately fighting low blood sugar, hypoglycemia. Certain cells, especially your brain and red blood cells, demand a totally uninterrupted stream of sugar to survive. So the body has to shift gears into releasing mode. Let's move to and see how this builds into a beautifully complex web of activity. When blood sugar drops, a totally new manager steps up to pull energy out of our organs. As you can see mapped out here, the liver, the muscles, the adipose tissue, they all start mobilizing their stores. They're breaking down those complex molecules and throwing them back into the bloodstream just to keep the brain fueled and happy.
The mastermind behind this entire rescue mission is glucagon. If insulin was the teller taking your deposits, glucagon is the body's ATM withdrawal mechanism. When sugar gets low, glucagon sounds the alarm. It tells the liver, hey, break down that stored glycogen. That's glycogenolysis. It triggers gluconeogenesis to build brand new glucose, and it completely unlocks the vault on our massive fat stores through lipolysis, breaking down triglycerides to release fatty acids so the rest of the body has something to burn.
Now we're really raising the stakes. Section 4, the stages of starvation.
We've looked at the normal daily ebb and flow, but what happens if the fast just doesn't end? Starvation actually rolls out chronologically in 3 distinct phases. Phase 1 is really just your standard post-meal fasting. No big deal. But hit phase 2, that's 24 to 72 hours without food, and insulin plummets, growth hormone skyrockets, and your body actually starts cannibalizing its own muscle just to scrape together enough sugar to keep the brain alive. Cross into phase 3 past the 72-hour mark, and the body hits the emergency brakes to survive. It drops its base energy expenditure by a whopping 20% and triggers massive lipolysis to just flood the system with fat for fuel.
Now, what's really interesting about this slide is the shift in preferred fuels. Look right there at the brain row. When you're well-fed, the brain runs exclusively on glucose. It's a total sugar addict. In early fasting, as we just saw, your body will literally destroy its own muscle just to feed the brain that sugar. But in prolonged starvation, the brain brilliantly adapts. It actually shifts to running on ketone bodies, which are produced from all that massive fat breakdown. It's an incredible evolutionary trick that spares our muscles, meaning we can survive for weeks on fat instead of dying in mere days from muscle loss.
And finally, Section 5, Stress and Other Hormones. So starvation is this slow, creeping, chronic stress. But what if, say, you're suddenly being chased by a predator? You don't have hours to slowly mobilize fat. You need explosive energy right this second. And that brings us to adrenaline. It's the emergency cash grab. When danger strikes, adrenaline bypasses all the normal bureaucratic red tape. It instantly orders the liver and muscles to dump sugar into the blood, and it aggressively melts fat. It even suppresses insulin, because right in that moment, you just need sheer fuel to fight or run for your life. The thing is, adrenaline burns out fast. If the stress is ongoing, cortisol steps up as the long-term project manager. Cortisol plays this absolutely critical, permissive role. It makes sure all the enzymes you need to break down fat and proteins are physically present and ready to fire. It amplifies the effects of glucagon and adrenaline, and crucially, it violently antagonizes insulin. It's literally blocking your cells from taking up glucose, deliberately keeping that sugar trapped in the bloodstream so your brain gets priority access during a crisis.
But yeah, there is definitely a dark side to this system. Check out the pretty shocking physical reality of chronic cortisol excess, which is basically when the body thinks it's under constant, never-ending stress. Cortisol's conflicting signals start causing this bizarre redistribution of fat. It melts fat from the arms and legs, causing muscle wasting, but then aggressively packs it into the center of the body. This creates what's called a buffalo hump on the back and a very rounded moon face. It's just a really stark visual of what happens when an ancient survival mechanism misfires.
Before we wrap this up, we've got to acknowledge 2 other major players at the bank. First up, growth hormone. Strangely enough, during stress and starvation, growth hormone actually spikes. It has a diabetogenic effect, meaning it raises your blood sugar by blocking glucose uptake, while at the exact same time telling your body to build muscle and burn fat. Pretty wild, right? And finally, we have the thyroid hormones, T3 and T4. Think of these guys as the body's furnace. They have a massive calorigenic effect, basically ramping up oxygen consumption and accelerating cell ion transport, which cranks up your base metabolic rate and generates a ton of heat.
So, here's the absolute crucial point to take away from all this. Our bodies are equipped with a breathtakingly complex, deeply ingrained system just to manage the delicate balance between feast and famine. Hormones like insulin, glucagon, adrenaline, and cortisol, they've spent literally millions of years evolving to protect us from starvation and sudden physical danger. But here's the question I want to leave you with today. In our modern world of endless snacking, 24/7 food delivery, and constant low-level psychological stress, how often are we actually letting our bodies utilize their natural famine programming? And what actually happens to these brilliant survival mechanisms when they're just bombarded with a never-ending feast? It is for sure something to think about the next time you find yourself reaching for a midnight snack. Thanks so much for joining me on this explainer, and keep exploring.